Hello, everyone. Welcome again to Space Apps. Thank you all for participating in this two-day event. We would like to kick off by thanking our organizing partners. First, our two founding partners, the New York Technology Council and Startup Bus. We have our venue partner, Microsoft, who has generously donated the space for this weekend. We have our live stream partner, the Internet Society New York Chapter. Our hotel partner, Yotel, which some of you had the opportunity to stay at last night. And our video production partner, PBS Digital.
Great. And yeah, please clap. Please do. We also had Yotel as our overnight hack location. We had about 30 hackers who came to hack overnight. They worked through the night. We bought them breakfast this morning as a thank you. Next, we just want to quickly just mention all of our celestial sponsors. Ooh, I just coined that. I like that. Intergalactic sponsor Microsoft. Thank you very much. Thank you, thank you. Interstellar sponsor and Space Apps Challenge global partner IBM. Interstellar sponsor Socrata. And also, I'm going to mention these three sponsors also are going to be presenting their own awards while the judges are deliberating. So they've been checking everybody's project descriptions, and they will, for the best uses of their technologies, they will be presenting their own awards. Next, we have Supernova sponsor Intel Mashery. Thank you. Supernova sponsor About.com. Supernova sponsor TouchLab. Supernova sponsor Twilio. Supernova sponsor SparkPost. And Supernova sponsor Double Dutch.
And we want to thank our exhibitors, the American Museum of Natural History and their Bridge Up STEM education program, the Intrepid Museum, Future Engineers, and MakerBot.
Okay, so without that, we basically are going to say the format is going to be 3 minutes of presentation and roughly 2 minutes of Q&A. But we'd like to next introduce David Hockman, who has been a judge for Space Apps NYC all 4 events that we've done. He'll be telling you about the judging criteria, and then we'll have all the judges introduce themselves.
Thank you, Mike and Alice, and I repeat all your thanks to the sponsors and of course to the organizers as well. It's hard to believe from the small event we had 4 years ago, we've become a NASA main stage. It's absolutely fantastic. So again, the judges will introduce themselves in a second because I'm the longest standing judge. I'm gonna start, but I'm far outranked in expertise by every one of the other judges, so you'll be thrilled to hear who they are if you don't know already. The categories we're going to be using are specified on the Space Apps website. We're going to be designating winners in best use of hardware, best use of data, most inspiring, galactic impact, and best mission. From among those, eventually up to 2 will be forwarded for global competition, and I believe you're going to be able to vote online in a People's Choice contest. We're going to use the suggested scoring criteria that NASA provides, and these are impact, creativity, product, which we're interpreting to be fit with the stated challenges, sustainability, which we're interpreting to be doability, implementability, and presentation. So there's always a chance to score on any one of those criteria. We'll grade from 1 to 5, 5 being the best, sum the totals, and that'll start our discussion in the room after the fact. So I'm going to return to my chair and ask the panelists to start introducing themselves, starting with Katie.
Well, hi, I'm Katie Coleman. I am a NASA astronaut, and I've flown a couple times. I think you saw some video just now of my crew up on the space station. You know, it's a magical and wonderful place, but the NASA mission is larger than the space station, and I'm really thrilled that our 36 challenges that NASA has presented to the Space Apps Challenge cover so many of the things that we need your help to do, and I am very much looking forward to seeing what happens.
Hello, everyone. I'm Deborah Diaz. I'm the NASA Chief Technology Officer for IT, and I just want to say thank you to all of you, and I'm so excited to see the presentations.
Hi, my name is Victor Luo, and I work at NASA Jet Propulsion Laboratory in Pasadena, California. I help lead the project with Microsoft regarding the HoloLens, and we've been able to take scientists and engineers to Mars as they explore and work together. So I'm a part-time hacker here myself, so we're really excited to see your projects.
Hi, I'm Emily Rice. I'm an astronomer here in New York City. I'm a professor at the College of Staten Island and a research associate at the American Museum of Natural History. I also have a space fashion blog called Startorialist, and I run events in New York City. I run events in... There's no way I'm cooler than an astronaut, you guys. I run events called Astronomy on Tap in New York City as well, and those are spreading around the world.
Now, you know why I'm outranked in expertise by every one of these. I'm a consultant in economic development, focusing on startup companies that come out of advanced science and technology, and I manage the Business Incubator Association of New York State, a statewide network of 40 mostly college and university affiliated incubators around the state. Let's call the first team.
Yeah, Oregon Trajectory, you are up. Come on up to the podium.
Hi everyone. Our team name was actually Died of Dysentery. So we did a play on the Oregon Trail, but in space. So I worked with a bunch of people from different countries. So we did Bulgaria, some people in Canada, and then we had a lot of different cities in the US, Seattle, Florida, New York. So we decided to do something on the Oregon Trail, kind of a play on looking into past history and hopefully getting not just students, but adults interested in not only STEM, but asteroid mining. It's something that we think is a space that could be very valuable for not just the public, but private areas as well. So I'll walk you through. You essentially go through and start trading in for rocket fuel and rations. And hopefully you have enough to make it through. Head through space and you encounter different stations, different debris, asteroids. We have little mini games set up. First station, continue on, start hitting different encounters. So you might have an experiment in space. Do you make the decision to continue? Do you make the decision to stop and waste fuel and potentially rations, where you might or might not get anything valuable out of it? Little tidbit, we actually used potatoes for the asteroids. So our favorite game while we were building this was Potato or Asteroid. So here you make it through. It also tells you what the distance is to the next asteroid or station. So you discovered an asteroid, what do? You can mine for resources. So we have little games set up and you can kind of maneuver and you try to shoot at the asteroid to try to mine it. So we're hoping to set up more of these mini games in the next installment. But you either got a lose or win, I guess, and I've done neither. Right, I don't think I have enough bullets to make this through. Yeah. Oh, we should, yeah, that's a good idea. For the next one, just get some mashed potatoes going. So we have that. You can either make it to the end, which is Europa. And actually, I think I can only get that on a local. So you can either make it to Europa, and in which case, oh, it's getting cut off. Well, stuff to return to. So here, the end of result of the game is that you make it to Europa and search for life. And we then hope to kind of explore further and kind of expand the solar system and where you can travel to.
Okay, questions from the judges?
So I'm wondering, where do you see this game? Do you see it just as a game platform? I mean, I know
No, we also hope to incorporate some external links, so starting to link out to NASA wiki sites, where it becomes not just a game but informational too, like little tidbits. If we're hoping to have an entry system where we'll ask you a question and then, hey, can you go here, find the answer, you'll get 100 extra points in fuel, etc. So that way it's not just isolated, and it's incorporating a lot of the community as well.
Right. No, I also just wanted to say, I think, it might be interesting to see in museums this kind of activity for kids to play in museums, and also just to say it's hard to be first. Everybody's thanking you for going through the technical difficulties, and we've all been there. So, and that goes for everybody else who has technical difficulties as it goes along. We all know how it feels, so thank you for going first.
Thank you. I was like, what are the odds?
Any other questions? Anyone? No? Great job. Thank you.
Thank you.
Okay, next up we have Spacebase.
Hello, everyone. Thank you for being here. We are called Spacebase, and we are a location-based data visualization system. We actually had an initial broader scope for our project where we were going to do some things with Watson and do analytics that way, but it turned out that was kind of out of scope. So we ended up using the Intel Edison to collect some data and on temperature and light sensors that my teammates will come up and talk about. And then we built an application to visualize that data, hosting it on Microsoft Azure. So with that said, I'm going to turn over to Mikhail, and he will fill you in on our project.
All right, so Spacebase actually lets you visualize the location-based data on the fly. So let's see how it works a little bit. First of all, the idea. Knowing when the critical environmental control systems fail is very important. So for example, if you have a leak in your Mars hub, you're in for bad times. Or if you want to see where the leak comes from on the International Space Station, you want to know which point is the hottest from the outside. Now, how did we acquire our data? We used Intel Edison here, and we walked around the room collecting the brightness points in the different parts of the room. We actually, due to the scopes of this hackathon, collected only 9 data points in corners and then right in the middle. And then we uploaded this data and upsampled it and smoothed it a little bit. And that's what the result looks like. Obviously, if we have more than one sensor and the data point collector, let's say maybe there will be a drone flying around or some robot running around and collecting the temporal data, we can get much more done with it. We can see if the brightness correlates with the temperature, and if it's not, then you probably have a heat leak, because otherwise you can just have the very luminous point that produces heat. And it also has a lot of other applications. So this temporal sensor data can be used pretty much anywhere from the asteroid information to, let's say, analyzing of the big red spot on the Jupiter or any other planetary science. Sadia actually has more examples.
Thanks, Mikhail. Other applications of data analysis actually extends into planetary and atmospheric pressures. We could analyze the dust of Mars or the red spot of Jupiter. Also, global warming is becoming a bigger problem every day. So with this sort of device, we could actually correlate temperature to brightness, because the reflection of light in the polar caps will indicate how much ice melt is going on. So this sort of device is actually really prominent and should be used by NASA or just any company in general. Would you like to add anything?
That's pretty much it. If you guys have any questions, we'll be happy to answer them.
Question, I'm wondering if you've thought about Earth-based applications like precision agriculture, things like that?
We sort of designed a framework for just analyzing sensor data. Right now, we don't have the temporal component to it, just because we didn't have time to implement it. But if you can analyze any data that has numerical component and the timestamp, you can start with the simple things like plotting the heat maps. And then if you add more functionality to it, you can do predictive analytics. You can integrate, let's say, Watson to it and infer things, like you can ask questions like, when will my system fail, or when do I need to add, if you're talking about agriculture, when do I need to add water or some kind of fertilizers. So any data with a sample point and a timestamp will be good.
Okay, thank you.
Thank you.
Thank you, guys.
So next up, we have Alien Detector.
Hi, good afternoon, everyone. Thanks God, the hackathon almost finished. Yeah, okay. So what is the alien detector? Alien detector is an interactive installation not installed in the outer space, because we didn't know what creature in outer space, right? So why don't we just create different, just several installation and put in the planet we want to observe? So in our project, we use the camera, not sense the motion, and sense the moving object, and then they take a snapshot and then send the image and the voice message and to your Gmail or iPhone. So let me demo a little bit the code. So once it sends the aliens, and it will send the signal here, so you see the light blinking. And I use the Teboo, T-E-B-O-O, to forward the Gmail and some message. And about the technical part, I have my teammate, Powell, to talk about how it operates.
So, what I'm going to show you here today is, this is a breakthrough in the alien detection technology. So SETI is dead. This is the future. So it looks gorgeous. You can see it's only like 9 millimeters thick cardboard. We use all the latest technologies from the Dunkin' Donuts tech department. They promised us that this cardboard actually is very resistant for high temperatures. They didn't specify how high, but that may be a problem. Okay, so what was the idea here, right? So as my colleague said, we have this sensor here, and the camera is supposed to be here as well. So, yeah, hold it. From this angle, it looks awesome. Right, so we have this ultrasonic sensor here, so like a proximity sensor. So whenever an alien comes up here, then we take a picture of an alien. Then we don't know at that point whether there's an alien or not, so we have to analyze an image. So what we are going to do here is with the camera, we take a picture, we save it as a BMP image, and we do the processing. So for the purpose of this demo, we only did like a basic image analysis, so we can maybe detect the colors. So we are going to make a like alien, green alien, put it here, and then we can, that's a BMP image, so we can go pixel by pixel, check whether an image is actually green, and then based on that, we can trigger an alert. So now I'm gonna show you, so whenever we detect an alien, what's gonna happen next? Then we have kind of two, we have like a voice messaging here. So there is a text-to-speech synthesizer, so we can alert you about the warning aliens. So I can show you how it actually works here. We have this. Have to run it from here.
Alien detected. You are going to die in 10 seconds. 10, 9, 8, 7, 6. Okay, relax, I was kidding.
All right. The voice recognition, the text-to-speech is not perfect, but at least it works. So technology-wise, we are using obviously Intel Edison and also Raspberry Pi. So
Okay, that's time. That's time. We're going to have to move on to judges' questions.
all right. So that's it.
Well, since if you read my Wikipedia entry closely, you'll notice that I was supposed to have seen aliens in space. I didn't write that, and actually I could tell all of you that I didn't actually see any. I made sort of a bad joke about aliens, but with this detector, maybe we would actually know the story, right?
Yeah. Obviously, we have to build millions of them.
Right. But is there any Earth applications you can think of for this technology as well?
You can put it into your door and then you spy on your neighbors.
Okay. Sounds good. Well, we appreciate you looking outward for us at NASA. Thank you.
Okay, next up, we have Team Kessler. Team Kessler is on stage. White HDMI cord with adapter. The hand mic you can turn to on if you'd like to use it, and the podium mic. Please keep your mouth close to both microphones. First on deck, Asteroid, solving Earth's resource issues. Second on deck, HMFS. HMFS. Okay. Take it away, Team Kessler.
It's like that dream that you have where like everyone in the audience is someone you know. Actually, it's more like that scene in the Avengers where it's like, we know how to destroy the aliens. So if we'll, if we're getting hooked up to the computer, hey, so we are Team Kessler. That's Adil, Will, Oscar, Nikolai, Olivia, and myself. I'm Katie. Hey. We've been tweeting hashtag Team Kessler, Kessler, kind of like lunatics, since we came up with the name sometime yesterday. That was when Olivia joined us and we realized we had to replace Katie and Du Bois because it was no longer just Katie. So getting started, this is our presentation. We're presenting a sort of data visualization software. So a wise woman, yes, at boot camp on Friday said to me, her name is Sandy Carter, she said, what makes you different and what makes you a minority, what makes you unique is what makes you valuable and what makes you special. So funny story, Team Kessler doesn't really fit in with one of the assigned challenges. We sort of just did our own thing, but it's an awesome thing. So we met sitting in that second row, was it yesterday morning when we were hearing speeches, being inspired. And we decided to talk about, through what Will and Adil had done in the past, we decided to talk about space junk. Did you know that in 2009 there was a sort of an international incident when the American satellite Iridium 33 sort of crashed into, collided with, as you will, with Cosmos 2251, which is a Russian satellite. So this is an example of something that Adil introduced to the group, which is called Kessler syndrome. And it was invented by a scientist named Donald J. Kessler of NASA. And it's basically, there's a lot of junk in our atmosphere. It's satellites you no longer use, just random stuff, dirt, yucky things. And when they crash into each other, they create more debris because they split up. And so there is more and more crap that we have to get through if we want to leave Earth. So we created a visualization of it. And so if we can head to the webpage, Olivia, this was an incredible coding project done by us. As you can see, we have using 3JS and an API called satellite.js. Ooh, there it is. This is Kessler syndrome. And basically, this is Earth, and it's rotating in real time. We can speed it up a little bit because the Earth rotates kind of slowly on the video, on the, sorry, the live visualization. So if we're gonna sort of make time move a little faster, the white lines are one of the 151 space pieces of actual space junk that we're tracking using a data set called TLE. And basically, they are larger than 10 centimeters, and we're tracking them, and that's where they are a couple hours ahead of us. And the red is where a collision is most likely to occur. So that is our visualization. If we can go back to the Prezi. We've got a couple things to say about how cool this project is, sort of the scope of it. One thing is that, zooming out right there, it is in real time. That's where the Earth is right now in relation to the sun and also in relation to the satellites. So that's pretty cool, we think. Yep, can we get the next slide? Yay, internet-based presentations. Okay, so, yeah, so they can use to be, the speed can be messed with, it's in real time, and the collisions can be predicted, which can be used. Next slide, please. We're thinking there's a lot of adaptations for this, not just because it's a cool, pretty picture. One thing we want to look at is, because of the Kessler syndrome concept, is that there is an exponential number of collisions. We want to potentially do that. Another idea is by Nikolai, which is maybe using this technology to encourage people to create solutions to the problem.
This is the recovery module that I've named Ares. It's based around firing around 380 gram mass of tungsten projectiles at the space junk at the perfect time in order to knock it out of orbit. Yeah. And sorry, premature. It could also, for the CPU to calculate at the right time, could use the power of the Intel Edison.
So we're thinking we could maybe even inspire a future challenge to maybe fix this problem. Another thing we were thinking of doing is maybe creating a wearable technology where you can stand anywhere in the world and your Apple Watch or your Edison bracelet can tell you that space junk is colliding above you, and you can wave at the space junk. Hello, space junk. Oh, thank you, applause. If we could have the next slide.
That's time.
Thank you, question.
Sorry.
Perfect.
When she does this, that means you guys.
Friends, comrades, family.
Thanks for the great presentation, guys. Just a quick question: if this application was real, if it was successful, do you think the premise of gravity would have happened?
Sorry, could you clarify the question?
You know, if you had this application as a functional software, do you think the premise of the movie Gravity would have happened?
Oh, well, I haven't seen Gravity, but I think Adil has.
Yeah, I mean, the idea is that the simulation is obviously very rough. It's not, it could use a lot of tuning. I'm not sure that knowing that a collision is possible to happen really has any bearing on your ability to prevent it. I wish it could, but I'm not sure that it would have made too much of a difference.
That's really an idea for like future challenges.
If we could get Sandra Bullock to shoot tungsten projectiles, that would be ideal.
That'd be great.
Yeah. Any other questions?
No, thanks. That's what I was looking for. Thanks.
And with the Ares, you need to remember, it's raining tungsten.
Oh my God. So yeah, we've become really tight. Thank you.
Thank you.
Thank you, Team Kessler. Thank you. Okay, next up. We're going to actually have a little bit of a change. We're going to go with Asteroid Ascent. Asteroid Ascent, are you prepared to come up?
Okay. All right. Hi, everyone. My name is Ariel Ekwa, and our team for today is Asteroid Ascent.
I'm Ariel Rowan. And I'm Courtney Wiggins.
I'm Isabel Ojeda.
And I'm Will Liu.
And we're here today to tell you a little bit about the Asteroid Future History Challenge. Oh, microphone closer. We're here today to tell you a little bit about the Asteroid Future History Challenge and how we interpreted this. So, Ariel, to start us off.
The goal of this project was to educate people about the ARM mission, the Asteroid Redirect mission, as opposed to other more well-known projects, such as the mission to the moon or the mission to Mars.
So we did this project in 4 different components. You can see here on our website that we've just set up. None of us are front-end developers. This is all of our first time hacking, so you'll have to give us a little bit of understanding here. So first we looked at asteroid data. We actually pulled real data from AstroRank and used some APIs to visualize some data about asteroids. I'll show you that in a second. Then Isabel can tell us a little bit about what we did specifically for the NASA page.
Well, we created like a separate page just to explain what the ARM mission is and how important it is. There are several links that link to different resources, and each of them have extra information about the ARM mission.
And the goal is that we made it very educational. So you can see, for example, this one will actually take you back out to NASA. We realize that NASA has so much amazing information always available on their websites, but it's hard for people to find what's relevant and what's not. So we've collated it and brought it into the context of the ARM mission, where, for example, for visual learners, if they really want the highlights of the ARM mission, they click here, and they're brought to the NASA Visual Highlights poster about the ARM mission. Here we go. And so we tried to tailor it for content, for facts, for visual learners, etc. Now, if we go back to the home page, we also have an educate page. And Courtney will tell you more about that.
Yes, so in developing our educational curriculum for Asteroid Ascend, we not only looked at our target population, which is students, we also looked at the greater community and their families to increase their awareness of the wonderful things that NASA is doing. So if you can change to the curriculum, we did a quick mock-up of a sample curriculum. There's only 2 sessions that are present here. But if this was given to an educator or someone in the community, they'll be able to assess their goals for the program. They'll be able to work through some of our workbook pages that we have there in terms of program forms. And also we have 2 sample curriculums that allow them to integrate both technology and education. In the curriculum, students will be working with Google virtual reality glasses, where they'll be able to make their own game. They'll also be able to construct their own set of Google glasses, decorate it, make it their own. And they'll also be able to use Unity to use their Google glasses in the classroom.
And customize a little bit of the Unity app. If the judges are interested later, we actually have an app that we did not create, but we found a space app that you can explore the solar system in 3D using Google VR glasses if you're interested, or Google goggles.
And very quickly with the students in the classroom, it would be wonderful if they could take their findings and share out at town hall meetings or community board meetings so people are aware of what's going on in space.
And as the final point, this is actually the asteroid data slide where we're trying to introduce students to the idea of data and of charts and make it very accessible in an easy manner. So we teach them a little bit about scatter charts in the context of asteroid diameter and the value of asteroids. We call out 2 cool stories series, which the NASA Dawn mission is actually currently exploring right now, about how much water might be found in Ceres, and then the monetary worth in the $195 billion range for one of the other asteroids that are known. And then the third component, Will tell you a little bit more about.
So we had some deployment issues right before this, so that's why we're switching around a bit. But there's a lot of good data out of the NASA pages. What we did is we went ahead and got some data from AstroRank, and we took that data and we basically put that into a way where you could learn based off of that data. So for this one, we're trying to solve what asteroid should you mine. So if you have like 2 asteroids and they have different resources, and it costs the same to get to both of them, we would go ahead and go for the one that has more resources. So what we did was we went ahead and pulled in 1,000 different asteroids, each one with a different distance, which we count that as a different cost, and then each one that has a different price based off of like what minerals are on it. So if we go ahead and say like our maximum distance is 10,000 that we could go, we just go ahead and put that in, and it'll go ahead and find the most optimal solution based off of the distances that we could go. So
Thank you.
Questions from the judges?
Was there one factor and why you decided to select asteroids to choose?
So we're very interested in educational missions. We're very interested in educational missions, and what really stood out to us for the Asteroid Challenge is that everybody knows about the Moon mission. Everybody knows about, we hope a lot of people know about NASA's Mars mission, but asteroids are amazing resources both for Earth and for future space missions. We felt like there was a lot of value in pitching that to society more broadly. Storytelling, exactly. Gotta get the story out about asteroids. So, thank you.
Any other questions? Anyone? Okay, we have another slight change. So the other asteroid project actually is not, that was merged with the previous team. So the next up is HMFS.
Okay, so my name is Rudy and this is Nicholas, and we did the project Happy Moments from Space. So basically what we did here was we created a way for like the local public to be more aware of what's out there in space, and a fun way to do it actually. So so here people would sign up and send their email in and have an account, and they would enter in a special date, like a birthday or anniversary, and you could just sign up here, right there. And we would have to email and password, and then we would submit, and that's going to, and then you would enter in a special month or date, and then you would enter a message like happy birthday or happy anniversary, and the message would be sent to NASA's database, and then a picture of that day taken from space would be sent to your email, kind of like as a present for you, like a birthday present or anything. And this was just a way to like make people aware of what's out there in space, of all the different galaxies and nebulas, the Hubble Space Telescope picture takes and all that. So he's just gonna explain like what in the background of it.
Before I continue, just to let you guys know, due to time constraints, like our website isn't complete yet, as you can see. We just wanted to get a kind of a rough draft out to show you guys. So the APIs we were incorporating with our website would be NASA's APOD API, and that's basically the API we would use to get pull the images from their gallery of images and send it to people via email. We were going to send out images using Spark Post. We're going to use Spark Post API to send those images. Yeah. So like, we have the general rough draft of the code to send out all this stuff, but we haven't exactly put it all together as of yet. But this is the JavaScript we would use to kind of like send a confirmation email that your account is done for the sign up page. For the form page, we'd be using kind of like a Ruby GET request to get those images from the API. And we would also be using kind of a library called UniRest, which kind of makes it easier for us to get those images. And also we would pull those images and put it inside of kind of like incorporated with Spark Post to send those images out. The mailing format would be something really simple. It's kind of just a happy birthday if it's your birthday, and just have the picture below it, and the picture would kind of would come with data of like where that picture was taken, the date it was taken, and like other information like that.
Okay, questions from the judges?
What does the date actually correspond to? What property of the image, I guess? Like when it was taken, or when the press release was, or what date it appeared on an APOD?
Oh, so the date you put at the, you're talking about the date you put at the, when you start for, okay.
Yeah, how does it correspond to, like what property of the image, I guess,
So what
does it
we were
correspond
aiming
to?
for is to basically get a picture, like if it's your birthday and it's like March 13th, you would pull a picture off NASA like on that same day, and it'll be like a random picture of, it could be a star, a place on Earth, or just anything on that day. And the whole concept is to kind of like make people, kind of like further people's interests without having to make them kind of like come to you to view images. You kind of send it out to them to make it easier for them to get interested.
Yeah. All right, thank you.
Okay, next we have HMFS. Is HMFS here? Oh wait, I'm sorry, that was you guys. Firsthand, I meant Firsthand. Okay, go right ahead. This is Firsthand.
Thanks Microsoft and Space Apps for an awesome event. This is Firsthand, and this is this is our robotic hand.
Hi everyone. Wearables is a new emerging category in the market of technology, which allows a better integration of humans and the computers to allow a better interface between them. And now, everything is getting smarter, smart homes, smartphones, but NASA was already producing smart stuff years ago, but the glove they have currently has a few drawbacks, such as nail delamination, limited flexibility, and limited thermal control inside the glove. And so our solution is Firsthand. That's how it looks.
So in order to solve these things, one of the first things we wanted to do is add sensors to the glove. Right now, I'm sure NASA has tons of sensors, but what we wanted to do is have a sensor on each finger so that the control of the temperature could be dialed in based on each finger, and the comfort could be, very, very exact. So we also found that there was an Intel Edison board here, and it made our hacking really easy. It sped up a lot of our time and made a lot of our processing just really quick. This here is a picture of how we're doing heat control. The white box is a thermoelectric device. It's hot on one side and cold on the other when you pass a current through it. So what we're trying to do is, if your hands are cold, you can warm them up, and the copper ribbons are ways to pass the heat to the rest of the finger. And if your hand is warm and you want to cool it down, you can reverse the polarity, and it does the opposite effect.
And the beauty of our smart glove is that positive system for feedback, because we want active system, because everything, the environment is dynamic. In the glove, these are human hands that are moving. So we want active sensoring of that data, the temperature inside, and to produce a good positive feedback system and to maintain the temperature inside, because these hands are the most essential parts of the mission. And our glove design, our prototype is also very durable. You see the materials used in there. It has many base layers also, because NASA looks into long term. We don't want it to be durable for just one EVA. We want it to be for multiple EVAs. And we can do the app demo now. This is our complementary app that goes along with the hardware. So this is our software part of it. It's an Android app that goes on the user.
So from here you could see it's probably blue. That it means it's cooling, and we have voice activated control. Hotter. And you see it turn red, it's heating now.
So he's feeling some heat in there.
Yeah, so I can click it again and do colder. Unknown command 0, oops. Colder. Now it's back to cooling again.
And thank you so much.
Okay, questions from the judges?
How do you guys think this would fuse into the next generation spacesuits?
So a lot of the next generation spacesuits feature something called the mechanical pressure system. What it is instead of using an air bladder, it uses just like wires that apply pressure to the skin. I think that in the future, maybe not for EVA, but for planetary travel and planetary exploration, we'll have more form-fitting spacesuits, more active spacesuits, and something like this, I think, would play into that, because a lot of those active spacesuits can get really cold, especially if you're on Mars or something. And you're going to need heating, you're going to need thermal control of a lot of your body, and it'll be really important in planetary exploration, I think.
Katie, what do you think? Would you wear this thing?
What's that?
Would you wear this thing, Katie?
Actually, temperature of gloves is a big deal, and we have right now glove heaters in our gloves, because cold hands have been a very big problem, especially if you have to spend a long time holding onto something cold. And we spend time during a spacewalk actually doing a glove check, because we don't have feedback. We don't know how, if the astronaut doesn't remember to sort of think about how they feel, and often you're really busy because you're focused on what you're doing. And so we take time to actually, let go, look at gloves, talk about it. And it would be great if we knew that the feedback was built in, the data going to somebody else who could watch it for us while we're working. Thanks.
Well, ideally, to solve that problem, we not only have the voice recognition, but we were thinking about using Google Glass to receive data such as checklists and temperature control. So that might be useful as well.
Yeah. Thank you, guys.
Okay, next presentation is NLP Hacker Clan.
So, how many of you guys remember this? Oh, yes. That was my first encounter with NLP. It was from that toy that I became interested in human and computer interaction, although there were certain words that wouldn't say back, but that's okay. So my mission is to create or build a better, querying system for NASA. Sorry, I had a long day, and it's just me. Thank you. Love you too. So what I focus on, NLP, I do the back end work. If I turn this into a professor, they would probably say, where's the rest? But that's okay. This is just some insight as to what I would normally deal with, breaking down parts of speech for a computer to eventually parse and then process. My solution to the data mining, the text challenge was to pretty much use NLP to not only create an easier querying system software for NSA administrators, but to also receive feedback and to use that for a NASA native linguistic library. I honestly feel, why shouldn't NASA be a #1 leader in linguistic data? It would help a lot for a lot of the apps that you guys designed today, voice commands, and would certainly help out with plenty of to serve as a platform for plenty of other technologies to come. So unfortunately, I do not have a demo. Again, my partner decided not to carry on, so I would love to answer any questions that you guys have that comes to mind.
Well, I mean, I've worked with natural language processing, and it's one of the hardest fields in software. So props, kudos to taking on that challenge.
Thank you.
If you had a bigger team, where do you think you want to go with that?
Well, one of the challenges was I actually started taking a look at Java for NLP, and I'm so used to Python. So this challenge was me challenging myself. And I decided to move forward with this and start using something like Jython, and start from the ground up and try to create a library as if it was to be used strictly for our NASA database.
Awesome. I'd encourage you to keep working on it. Yeah.
Thank you. I appreciate it. Thank you, everyone.
Okay, next we have Cadographer.
Good afternoon. So our project is Cadographer. I'm Mike. This is Keisha, Elaine, and Joe. And we'll talk about what Cadographer is. The CAD stands for Comets, Asteroids, Dwarf Planets. It's our answer to Visualize the Asteroid Skies challenge. And this is really an outreach kind of application. It's to make asteroids interesting to the general public. So we put together a 3D zoomable solar system that you could plot asteroids into and start to learn about them. So what makes asteroids interesting? Well, for our app, we decided to go with eye candy and basic human emotions, fear. Asteroids can come and kill you. So we grabbed some data about the likelihood of particular asteroids hitting the Earth. Greed. Ooh, all that platinum. Wow. Mention how much is out there and everybody's eyes light up and they never think about what's going to happen to the market for platinum once you get that all back on Earth. But the ultimate goal is to make people more interested in this. We've added in links so that they can get involved with the Grand Asteroid Challenge that NASA is promoting and put more citizen scientists out there, make the data set better. It's a virtuous cycle. So I'll hand it over to Joe, who will demo for us.
You can go ahead and just zoom around.
All right.
So
let's just reload that. There we go.
we don't need to. So this is a WebGL demonstration built in 3JS. I think another project, Demo 3JS. But it's an interactive 3D map. You can kind of see the lines. It's a little opaque, but you can zoom in and out. This is a solar system. Everything is to scale except to the sun because the sun is really big. So we kind of want to move that down. But this is an interactive solar system. There was not one built for me to use, so I had to go and build one myself and took like 90% of the hacking time just building this. So we do have demos of actual asteroid data. If we come down here, we built an API. Mike can talk about that a little more. That's all his work, but basically we do hit up a bunch of APIs to record and query through asteroid data. So we built a little tool right here to show you that we actually do have that data. If I come in here and type in an asteroid, I'm pretty sure this is gonna work. What was it? 2040. That's a really bad science name for an asteroid, 2014 DG. But it comes up with a bunch of data that we found on it. So with this data, we could plot orbits of asteroids, how close they come to Earth, how big they are, how dangerous they are. But again, I got tripped up on drawing ellipses in WebGL. So yeah, thank you. This is live. If you go to our GitHub page, we have a link to we have it hosted on Bluemix. Thank you, IBM. So you can go on there, check it out. Again, it's a hackathon. I did not try this in any other browsers, so go on Chrome or let us know if it's broken anywhere else. But we're hoping to open source this so that other teams can come in and build projects like this and not have to spend 20, 30 plus hours just putting the orbits of the planets around. Very boring.
Thank you.
Any questions?
What are the pulses coming out of the sun? Was that meaningful?
No.
I thought we had found aliens.
We were talking about eye candy, remember?
Yeah. Flash.
Solar flares, perhaps?
Did you think about including any imagery as well?
Excuse me?
Including any imagery
Yeah,
pictures?
actually the objects can be texture mapped. And definitely, if there's an API that we can hit to take the object designation and pull in a picture so that it shows any kind of images that NASA has on that, that's totally doable.
And real quick on that, there was the other project that did have a WebGL with the was it space debris. There is a plugin. Yeah, you guys, there is a plugin to just go and build texturized planets. It was just low on my priority list, so that is available. We could also build suns and moons, everything. Texture is definitely on there, but I thought the neon blue grids looked kind of cool, so I just left that in.
Any other questions? No? Okay. Thank you. Okay, next we have How Does Your Garden Grow coming up to stage.
So our team is part of...
Please get close to the mic, please.
Oh, sorry. Our team is a little split up. We have Sayara, she's a UK-based data scientist. We have Kwan, he's in Boston, he's with LavaWorks. And they came up with this challenge, with this project. And I met Kennedy yesterday, and we found them online, and we asked them if we could join them and help them visualize. I'm going to hit this play on this. Okay, so the project is what they wanted to do. They picked their challenge, food direction, because they wanted to see if by visualizing existing data about shortages and abundance of food, they could convince people that world hunger can be eliminated. Now, they also felt that it was really important that there was a full audit trail behind the analysis. And this is Kwan doing this, and hopefully we can get him on Skype later, so if you have questions about that, you can ask him. Well, so if people had accurate information about the factors that affect food shortages, could smart global farming and smart global agriculture actually help prevent world hunger? And could it even be eliminated? And if world hunger is eliminated, will that affect world poverty? And will that affect, will there be less conflicts? So based on existing food production capacity, experts think that we could feed everybody in the world. But we have to do a much better job of managing and distributing food. So part of that job then can be based on numbers, and those numbers exist. And so by looking at the numbers and by charting them in an interesting way, people, NGOs, activists, citizens can use them, and they can be able to much better predict and maybe even be prepared for future catastrophes. So say, for instance, that you have natural disasters or conflicts or epidemics or outbreaks. You use data from previous cases, and you look at that data, and you can be better prepared for when it happens. So we made a website for that.
Yes, I'm a web developer. So the last few slides that you saw were the website that I was working on. So the idea is somebody would go to the website, they would see the different graphs that are up there. I was trying to make it interactive too, so that they could play around with it and see what would happen in different they play around with it, see like what did it look like, food distribution, crop yields, things like that, and like hopefully inspire them to say there is enough food on the planet, we can distribute it elsewhere. So here are some of the graphs. The one in the upper right-hand corner, you'd be able to move through the year and see like how agriculture grew, employment in agriculture kept growing. So it's still a work in progress, but this is what we're heading towards.
And so then I just want to mention that our team members then that came up with this idea that we thought was so inspiring that we wanted to work with them on it, they have been sitting with and analyzing a lot of these numbers. So they would have a little bit better information maybe with what they've come up with in terms of, oh, these are actually numbers and something that you could use. We spent a lot of time on visualizing it. Okay.
Questions from judges?
The team. Can we go back to the team?
The team page. Can we hear you?
Yes. So, are there any questions? Anyone?
Any judges? Questions? Anyone?
Again, where were your team members from?
UK and Boston.
they have any comments there on the line there?
Yeah.
Do they have any comments they want to add? You can just hold the mic up there.
Yeah.
Hold on.
Global team for global problem.
It's, yeah.
Should I Skype them on here?
Yeah.
Is that okay? We just
Hold on.
listen.
Hey guys, do you have anything you want to add to it?
No, sorry, cut out for a moment, but I think it sounded pretty good so far.
Okay. That's
Okay, great project, guys.
Thanks, guys.
Thank you.
Okay, next up we have New York Space Tag, NY Space Tag, coming up to the stage.
Hi guys, so we took on the challenge of digging through the NASA data to find unexpected things in there, starting off with the tagging they'd done on their own data first of all. It's Mike, Tim, and Irina who's sitting over there. And so the first one was, what was the problem? What were we actually trying to solve? And the trick here is that NASA has released thousands, tens of thousands of data sets. And the tagging that's been put on there by people is patchy and a little idiosyncratic, as we found out fairly quickly when we went digging. For example, there's only one, there we go. For example, there's only one data set that's tagged space. On the other hand, there are hundreds of data sets that are tagged with agriculture. So by NASA's own tagging, it looks like NASA is predominantly to do with farming. So I think we might talk about that later. It makes it difficult to search. It makes it almost impossible to find connections between data sets. And the other thing is that it's not just NASA, right? So all of the other government agencies use work that NASA produces that relate closely to stuff that NASA does, particularly the NSF, the DOE, the Department of Defense. And there's no unified tagging across those sets. There's no way to line those up. So the project brief gave us metadata on 70 of these data sets. It's a pretty good starting point. We tagged 16,500, which is all the ones from NASA we could find. And then we tagged another 10,000 from the rest of the government, because we could. So we're up to about 26,000, and the only reason we've stopped 26,000 is we ran out of reliable sources from the government. So if we can talk to them and get a few more, that would be great. There was a bunch of math. This is where the NLP came in, so there's a lot of natural language processing. When you're dealing with hundreds of words per data set and tens of thousands of data sets, you're up to millions of words pretty quickly. So being able to pull just the important few from that becomes a little tricky. Thankfully, we have people on our team with very deep research experience in natural language processing, so it wasn't quite as scary as that math might make it look. And the solution, the product, what do we build? A database, which is less exciting than it might be, but bear with us. This is just solution one. So we use a bunch of various natural language processing points in here, but just note here, there's things like looking at the frequency a word is used with. Just because it turns up a lot doesn't mean it's important. Actually, usually that means it's less important. Looking at entity recognition, so not just taking the terms where they appear in a sentence, but actually figuring out, is this a thing, right? Is the International Space Station, is that string of 3 words referring to an actual thing? And that gave us some pretty intuitive keywords, right? So International Earth Science Information Network was just something automatically extracted from these millions of terms with no human vetting by us. That was just something that fell out as one of the top 10 terms that came out of parsing all of this data. I have no idea what that is, but thankfully all the data does, so that makes life very straightforward. Oh, there we go. It's stored in a web-accessible MongoDB, so it's actually accessible not just to the applications we build, but to everybody. And it's trivial to run a new data set. So as we get more data.json lists of data sets from the US government or from anybody else in a similar schema.org oriented format, it makes it very, very simple to fold it in and cross-tag. So some stats. Keyword tagging over 26,000 data sets has given us 188,000 keywords, 12,000 of which are unique, so there's 12,000 individual unique keywords in that set. And the tag keywords cover 7 other agencies, 12 US states. I won't call out the names of states that didn't have their data sets in there yet. And connected 3,000 of the NASA data sets directly cross-tagged with other department data sets. But there's more.
That's time. That's time. Do you guys want to eat into the question time? Do judges have questions?
Yes.
Do you want to do the demo, or let's see if is there a question?
So just a quick note here. This is a graphical demonstration of the relationships between the data sets for human spaceflight. So you can directly mouse over and pull up specifically those keywords that are related to human spaceflight directly. So that's all the various data sets. And you can go directly to the data set itself and actually download it. All the websites and the deeper information is there. And you can see that human spaceflight, it turns out, is heavily correlated with communication delays as one of the major issues in human spaceflight, which we had no idea about until we started looking at the way that people had cross-tagged their data. And you can see these constellations for every different search term. So this is for space, and that is for climate and climate change, which is a highly interrelated and correlated set of keywords.
So a question, this seems to bear some relationship to systems that are used to cluster publications, patents, things like that. Have you looked at those parallels? Is your intention that the NLP-based tagging is used to help humans better define human tags, or to exist in a parallel scheme of NLP tags?
So for this one, because of the large complexity and number of organizations involved, trying to get a uniform human tagging of all of that data is unlikely, I think. So having at least one uniform view, which you can pull from a programmatic version, has high value. But we also have all of the same exploratory analysis and visualization for the human tagged one as well. So you can do the same exploration through people's own human tagging, which actually gives you a different and interesting view over the same data sets with kind of fuzzy matching. And we did a bunch of synset work, so now you can connect air and atmosphere, now actually connect those two data sets together, even if one was tagged with air and the other with atmosphere. Because of the fact they're synonyms, those two things are connected for the first time. So we rely less on the human tagging, even though we can use the human tagging.
Cool. Thank you. Anybody else?
Anybody? Okay. Thanks very much, guys. I love to see that applied to like the New York Times archive or something. Okay, so next up we have Star Map. What the crap? Is Star Map here? Star Map? Are you on the wall? No? Okay. Dems, are you ready to go? Okay, come on up. Dems, drone ecosystem for Mars surface surveillance. We have a drone.
So we have like a complicated name, drone ecosystem for Mars surface surveillance. Not that complex actually. Quite a simple concept, to be honest. Oh, and let's start with a shout out to Yuri Gagarin, 54 years ago today, first manned space flight. So that's awesome. That's where it all started, I guess. Okay, so to give you a quick introduction, this is how we start. Currently, we have a bunch of satellites. So a bunch of them work, bunch of them don't work as functioned. But yeah, it's a huge cost to send any of these satellites to space. Moving on, we also have some rovers, which, it was the in thing a little while ago. We had the Curiosity rover, the Opportunity rover. Just a quick note, if the Curiosity rover had to climb vertically the Empire State Building, it would take it close to 3 days. And that is one of the problems. Like, it's a little slow, it has its own shortfalls, clearly. And that's what we want to address over here, moving on. So what are the shortfalls that we are trying to address? If I wanted to be like really quick, there are 3 different shortfalls or 3 different concerns that I want to talk about. Cost of development. Satellites, really expensive, nothing under $60 million. Speed, daily coverage. As we just discussed, 3 days to cover Empire State Building would be too much for a trip to New York. And buoyancy. The problem is that the energy is really short. Mars is far away, and solar energy does not reach as much, and the air is thin. So if you want to fly a copter over there, it's really difficult because of the density issues. So we try to solve that using buoyancy, and you can see it over there. Yeah, it flies most times. So what are the ideas that we have, or the options that we have to solve these issues? Whoa! Okay, excellent. Okay, so moving on. So the issues, now this is just a quadcopter because indoor flights have to be safe. We don't want to kill people around here. We bumped into a lot of you guys, and you guys know it. And the noise, oh my God. So this is the design. Could you pause it here? This is the design that we are actually proposing that we would want to go ahead with. It's got 2 rotors just for thrust. The final third tiny rotor behind that you see, it's for stability. But those are not the rotors that will give it a lift. The lift is entirely provided using a huge balloon. Now this balloon is not as big as we want it to be, but yeah, it can be done. It has been done on test levels, and this is our idea. The lift, the amount of mass, which we are looking at around 3 pounds to get covered. So those are the kind of things we want to do with this drone, and There will be a bunch of sensors which would do tons of different things, visual camera, infrared cameras, and we will also be looking at generating all that data and trying to focus the data, not using our own comms. NASA already has done excellent work. Other orbiters have done good work. So we will be, our primary drone, there will be a system of 5 drones. The central drone is the primary, which actually connects to one of the ground stations and a bunch of satellites who would actually be sending all the data back home for processing. We'll be using excellent systems, but for that, I'd like to invite my friend Prag, who is our technological head. I'm just the...
All right, whatever that meant. By the way, that was how a drone sounds on Mars. All right, so basically, our tech stack consists of a chip. In a nutshell, it's a chip on a drone. The chip talks to other chips to the auxiliary drones that he said. There's a primary drone and there are auxiliary drones, right? Okay, so how does the whole thing work? The chip basically could be using radio transmission services. Right now we're using the Intel Edison provided by Y. Thanks for his excellent support. But yeah, so basically what the chip does is, there is a small Python program on the chip. Now that program is actually ran by a service which runs as a background service. And this constantly pushes data. So right now we have a thermal sensor, right? So the thermal data is constantly pushed to the server real time. And we are actually logging that data and we can actually show it. Maybe let me just go there. Yeah.
That's time, guys. Okay. You're at time. So we're going to have to start questions.
All right. Can I just, refresh,
bring it up while
refresh.
we have questions from the judges. Anyone would like to ask a question?
So that's real-time temperature data that we've been collecting. Okay, questions?
Okay.
I just really wanted to say that.
How do you imagine this being powered on Mars?
All right, so there are a couple of ways we are doing that. Firstly, as I mentioned, power is a huge concern considering less solar energy and very low density of air. We want to cover this with solar energy, and we want to have it entirely embedded in plates. Even the balloon material, it can be covered with a silicon plate, and which is flexible enough. And Chinese experiments, which we have looked at from very, very secondary research point of view, but those work. But the good thing is that we are not using that for lift at all. First, when the takeoff happens, the rotors will stop. We stop using the solar energy at all. The energy is only utilized for analysis purposes and only to give a course correction sort of a thrust. Like how there's a xenon ion concept, which goes to Mars, there's a rocket, it goes on its own, very little thrust is actually given out, and the main thrust is used only for course correction. Except for that, everything is gravity-based. This will do something exactly similar to that.
Right. So basically, the rotors will only be used for directional purposes. The lift will be done by the buoyancy, pretty much.
In short.
It's a cool idea. We're looking into having a helicopter, a tiny one, on the Mars 2020 rover. I don't know if you guys investigated that. For the buoyancy, what type of air are you going to have in the balloon, and how will that perform on Mars?
We started with the idea of helium because, on Earth we use helium for almost everything. We noticed that hydrogen is not combustible on Mars, so yay, that's a big win. But the problem is we have to send all the hydrogen from here. Mars is rich in argon. We noticed 2% of Mars air, based on the incoming or outgoing carbon dioxide, is argon. We can use that. Argon is dense, we understand, but argon is lighter than carbon dioxide, and with sufficient amount of inward pressure, it can create sufficient lift to lift a 3-pound drone up in the air. Within some tiny math, we might be wrong, but we will correct it in the next few days. Because the main idea is to, in the next few days, we want to, the data streams that Prayag just mentioned, we want to overlay them with the time series so that with the time, exactly at what time, what location on Mars, there's a general API about Mars that NASA is developing. It's still not on Socrata, so thanks Socrata for helping us out with that information. But yeah, we will be using that once it's ready. Jason told us that we can be probably looking forward to getting that in the next 7 days. So yeah, something like that.
Okay, thank you guys.
Thank you so much.
Great. Great job, guys. Ooh. So you're gonna have to watch out for emergency weather conditions on Mars with that. Okay, next up we have what the crop? What the crop? It has a question mark at the end. So I'm gonna what the crop?
Hi, good afternoon, everyone. First of all, thank you organizers for having us here. It has been a great 24 plus hours. So once again, thank you, everyone. So what the crop is what the crop. Okay. So What a Crowd is made out of 4 members: Sihao, Marilyn, Hardy, and myself, Zian. And What a Crowd is basically a project built on IBM Bluemix with heavy use of Twilio. So What a Crop is What a Crop. There has been so many projects that have brought us all the way out to space. My head is growing so big, it's so painful now, and I want to bring you back to Earth. Okay, we want to look at problems on Earth. So what is the big problem on Earth? It is the shortage of food. Okay, so primarily What a Crop tries to solve the food shortage problem by helping farmers grow better crops, by improving the yield of crop. And to describe What a Crop in one sentence, it is crowdsourced crop alert systems for farmers. Okay, the primary interface that farmers will use to interact with What a Crop is not through the iPhone, but through text. Okay, so farmers will report the status of their crops, including the crop type, pest infestation status, the harvest ratio, to our system. And our system will collate all this data, crowdsource all this data from all the farmers that update their statuses onto our system, and try and make intelligent risk estimations based on all this data to remind or alert farmers about possible pest infestation, extreme climate changes, and other conditions as such. This is to give early warning systems to farmers so that they can prepare for harsh weather or make precautionary measures. Okay, so we have a demo right here. So you want a demo? So if you are willing to pull out your phone and send a text message to this number, 201-596-6238. And I hope this goes as well as your demo, Ricky. I'm not sure it will, but fingers crossed. So the kinds of data we take in is just a comma separated value. So you just put in the name of your crop, for example, sugar baby, sugar beet, comma, and comma, something that has to do with your pest infestation. So for example, you spotted armyworms, so you key in armyworms, and the last few is something to do with your harvest or your yield. So 10, I don't know what it's gonna type, 10%, 20, what are you typing? Just send it, come on, we don't have time. Yeah, so he's gonna send his message, and we are gonna respond. We're gonna respond something. Okay, we're gonna say that it's recorded, so the system has received the message. And an example of an alert system that will be sent out is. Okay, cool. Got it? Something? Yeah. So you can see this is an alert. So obviously this is a hackathon. This is pretty much hard coded, but we have other plans. So this is a warning saying that, oh look, it's a 51% possibility of this infestation. So be prepared. Maybe there's a fire, so in the region, so take precautionary measures. Maybe you want to change the crop that you're growing and stuff like that. So other things that we can do besides sending individual message is to send a message to an entire region. So we track which state the message comes from. So if there's a possible pest infestation on the West Coast, we can send a message to all farmers in the West Coast who have used our service and try and warn them about the impending critical weather conditions, for example. Yeah, so thank you.
Okay, questions from the judges? Any questions?
It's also always impressive to see a live demo, so good job, guys.
Thank you.
Very brave.
Thanks to Twilio and IBM Bluemix.
I'd love to see like a visual, like send back an image or send back, some other kind of, there's a lot of text on there, so I wouldn't mind seeing some kind of great project, guys.
Yeah, I did have one question, which is the data all just what a person observes and types in, or do you envision sensors on the ground that could automatically feed data?
Okay, so primarily right now it's from the data that farmers collect. So as you can see, the data that they send to us can be pretty crude and very messy at times. So we try to make use of a lot of data points, crowdsource it, and try and make sense of what the data actually means. So if we have a lot of data points from, say, the West Coast, we can try and estimate or guess what the farmer is actually trying to say. And we want to combine this with data from NASA. NASA has a lot of data on agriculture and as well as irrigation. So we want to combine this together with, for example, climate conditions and try to make sense of all this mess. So right now it's the data, so because we want to demonstrate this application, but there are definitely intentions to combine other data sources as well.
Great, thanks.
Thank you.
Okay, now presenting eMeteAidor. I think I'm getting it right now. eMeteAidor. First on deck is Hamstronaut. Second on deck, Share Space Science. So please line up Share Space Science. Thank you.
Hi, my name is Tae-Hong Min. I'm a computer science and business major at Lehigh University. I'm a junior. So instead of creating an application that will maybe one day potentially be something and that will probably cost around billions of dollars because it's NASA, over the past 24 hours, I decided to create something that is practical because this app practically cost me nothing. I used Microsoft Azure where they gave me free, I don't know, $100 or $20. And that will one day, and where even if I don't win, billions of people who have internet will still want to use this product or at least want to know in the back of their hands that they know that this product exists or this service exists because it'll save them time and potentially their lives. So I created an early protocol service system called eMeteAidor. So it's an immediate eMeteAid service web system. So I built this on Azure websites because Microsoft's awesome. And so we have two different dashboards. We have the admin dashboard and we have the user dashboard. The admin dashboard is like a really quick thing. So this website is assuming that a meteor has crashed or a meteor is on its way. Unfortunately, I wasn't able to find a software that detects meteors and meteorites, and apparently there's not one open source anyway, so I got lucky. So this is a very simple UI and UX where I used Google's API to locate where I am and meteor impact. So it just assume that there was a meteor impact here. That's why it says it was here. And it gets the latitude and the longitude. And you select the urgency level, which ranges from level 1 to IGES, because I feel like IGES is like the strongest. And then you send alert. Now, I wanted to send alert, depending on the urgency of the situation, I wanted to increase the range and send out alerts to everyone within the distance. So I tried to use Wireshark to scrape public IP addresses from in New York City, but then I realized that would still be illegal anyway, so I stopped doing that. And Twilio's $20 or how much? I think $100. If they gave me that much, it wouldn't cover like everyone in the distance. So that's a theoretical approach that I would like to take someday. But this isn't just simply an UI. After pressing send alert, I don't know why I did this, but I used Yelp's API through this branch of the site, where I put the latitude and the longitude within the my Facebook's parse backend, because that's what I use for backend, and I use it for the user interface, which is the meat of my thing, because the admin interface was supposed to be like a quick 1, 2, 3 thing. Everyone knows that there's a meteor going on, and it also sends nearby shelters. So I use Yelp's API to I used the Google's API to put in the longitude and the latitude into the Yelp's API in order to find the nearby shelters around New York City. So these are all the homeless and the rescue centers around New York City. And I also use the longitude and latitude to search up nearby hospitals. So these are all the nearby hospitals within this building right here. Now, not only will they be able to find nearby shelters and hospitals, by using Venmo's API, I was able to see all the transactions that I had that's under $20 to see if I want to maybe donate to like other people who had disasters. So on the bottom, I realized that Venmo doesn't really have a good button for like paying. So I use PayPal's API to donate money. So if you press donate here, it takes like 2 seconds. But yeah, so it might Gmails on the top, but you'll be able to donate money instantly to those in disaster. And at the end, I want to use Bluemix's API for the Watson thing, but unfortunately at the last minute, I realized it wouldn't work. So instead of the Bluemixes, I decided to use the Bing's API, where I can search my own meteorite. So let's say I'm looking for a meteorite called Apophis, which is supposedly a meteorite that will destroy Earth in 2036, according to NASA, I think. Am I right? So you can search up. That's like just like whatever in giggles to like search up whatever meteor you want. So this is for Bing's API.
Okay, that's time. Do we have questions from the judges?
That's clearly a pretty neat hack because you're using every single API possible in here, except for maybe hardware. But yeah, good job.
Thank you. Questions? Other questions? Any other questions?
Well, just a comment. I like being so resourceful, and and just look, if this doesn't work, I look at this and I find this, and the problem itself in terms of understanding the meteorite problem, surveying the sky. I mean, that's our immediate concern at NASA, is to survey the sky.
Right.
And we're trying to use crowdsourcing and basically telescopes all over the world to help us understand the data.
That's what I want to use the IBM Watson's Twitter thing for, to like see what people are saying about like meteorites in general. But I couldn't like get it to work the last second, so I put something else that's useful instead, which was the Bing's, because the Bing is the best search engine.
Well, and something that I wrote down was, unfortunately, I couldn't find a source that predicts meteors. I'm hoping that in not very many years, that's not going to be true. I mean, that's exactly what we need. So, Thank you.
Okay, next for the stage is Hamstronaut.
Hi, my name is Bura. I'm the product manager and the co-founder of Hamstronaut and the junior developer. Why we are doing this? When we were trying to find an idea for the hackathon, we were looking at this and then I said, okay, I can find what I need to see, or like probably anybody here, but what about young lady here? Or the other young ladies and gentlemen? And then I thought, what if there is something just we can encourage the young generation and the future astronauts? And then, so basically, as everybody knows, NASA has so many amazing photos, but it's a little bit hard to reach them, especially for young generations. And we came up with this idea. So we get those descriptions and the photos and merge them with some stories. Then teachers, parents, sisters, brothers, anybody can read, the young generation, or if they know how to read, they can read by themselves and also look at the real information without any story when they feel they are adult enough to be able to understand. So how we did this?
Okay, so how we did that was that we use basically a responsive web app. So basically, you can look at them. You can look at a website on a desktop, or you can look at it on your tablets or iPhones. We're using the APOD APIs, and the backend we're using Parse and Node.js. So let me just walk you through to Hamstronaut really quick. So when you come, let's see. How can we make it bigger? Great. So when you come to the home page, you see a little hamster, in a spaceship. He's on a mission hamster spaceship. And you scroll down a little bit, there are two options. Like Bura mentioned, if the kids themselves can read, so they can go here, go to this option, and read it in a smart mode. Basically how we all adults read pictures on Instagram, so Flickr. So this is the the adult mode. So you can see that, all the space photos light up here, and they can read the little description here. But if it gets really boring for them, so they can come back to their home page, and maybe with some adult assistance, they can come to the fun mode. And so this is basically a story that Bua wrote, based on the description that you guys saw from the other photo. So, once upon a time, there was, a kind of like a fun storytelling, style with like little icons for them to easy to, understand. And, the language is changed so that, kids can really understand it, And then they can see like a little, real photo, just to get them really inspired and get them really, loving space, because there's just so many photos out there, but there's really no an easy way for them to reach that. So that's the inspiration. And yeah, so let's go back to the, let's inspire the next generation of astronauts. And it's a one giant slip for the tiny mankind. Oh, and that's our inspiration. He's a hamster. His name is Startup. So.
What was your age group that you designed this for?
The age group is we're thinking that in like kindergarten, in the fun mode. So the teachers and parents can read the fun mode with the children. With the serious, like the smart mode, like elementary school, maybe a little bit, in the like 4th grade and up, because the terms are very technical. I think like if it can even go to like middle school. Mm-hmm. Okay, great. Thank you.
Okay, next project. We're actually going to move Share Space Science further down the line, so the next will actually be Planet Walk.
1, 0. 3, 2, 1, 0.
What's up, Space Apps? We are Planet Walk. My name is Gina. I'm a developer in New York.
My name is Edgar. I'm also a programmer in New York.
Come on, Edgar, in the mic.
My name is Edgar. I'm also a programmer in New York.
So we decided to focus on sort of engaging a younger audience, but this could be for anybody. I kind of grew up reading Discovery Magazine for kids and National Geographic, and I sort of like interactive experiences, especially as a kid. So this is Planet Walk. It's a kind of snazzy-ish UI for navigating our solar system. So when you come to the page, you get a little boot up sound. You can click play and hear some satellite noise. You can drag your rocket through different, can you see that? Yeah. Through different planets. So let's go to Mars. The planet changes. You get a blurb that we pulled from NASA's solar system website. Oh yeah.
We spent some time writing a parser for some of the NASA data.
It was pretty bad, but that was a really good exercise building a parser for a hackathon.
Yeah, the parse data actually comes in the bottom right. That's actual data.
Yeah, and the top left. So as you change, you can see mean solar days relative to Earth. You can see, fun facts. In the future, we'd like to, since we only had, as much time as you guys did, I think more data parts, maybe making this work in another browser besides Chrome would be nice.
Yeah, and this is actually up online. There's the link right there.
But don't go on your phone. I mean, you can, but all right. And I think that's it. We can do questions. That was pretty quick, right?
Thank you.
Yeah, you're welcome.
I'd love to see an even younger oriented version of that too. That's almost like a speak and spell or like an interactive toy. For a little kid, that would be really cool too. Okay, next up we have Dental NASA Augmented Reality Lab using wearables and self-sensors. Are they here? No? Okay. All right, so next on deck, Demeter. Demeter, you're coming up?
Hello, everyone. My name's Regine, and we are Demeter. I just wanted to introduce the team. Here's Salim. She's setting up for us. We have Finn, Kirsten, Jacob, and sorry.
And I'm Lucio.
Lucio, sorry. And Lucio is going to start us off and tell a little bit about Demeter, the goddess of agriculture.
Yeah, so our name comes from the goddess of agriculture, Demeter. And what we wanted to do was visualize how the global food production system works. And we didn't want to go so far as to try and advocate for certain solutions to this problem, but we wanted to create a forum for people to have the conversation and start thinking about what potential solutions would be. So our idea was to visualize different countries and what different food production levels that they have. We weren't able to actually get the data into the website, but that's kind of what we're hoping to do in the future, is to explore the food surplus and the food dynamics of different countries, and then let people have a conversation about why some countries have more, some countries have less, and why the food isn't getting to where it needs to be. So that's what we did. Thanks.
So I'm going to scroll down.
Do we have questions?
Can you explain what the red and blue mean again?
So the red, blue is to tell you which country you're selecting. So the idea is that we want to know if we want to be able to visualize which ones have more. So if the U.S. has a lot of what?
Is there a connotation?
So the idea is that we want to be able to start the conversation about why one country can't give another country some more aid or something like this.
Right, but does blue mean they have too much or too
no,
little?
No, it means you clicked on it first.
Okay, I see.
What we're trying to do is you input your nation, and then you click on another one, and you get connected to them. It's a forum pretty much, and you'll be able to ask them information. And we also have a few links. I think they're toward the bottom. Yep, where you can see some of the information we've already provided, because some of the NASA information was weird, so we had to get our own. Yes, it's so weirdly good that we couldn't get it.
Thanks, guys. We get it. Our data.
Yeah. And because we won't know the dynamics of those places, we're letting the people find out themselves by interacting with each other how to solve the problems, why isn't this happening, how to get with each other. You guys want to add anything?
I don't have anything.
Thanks, guys.
Thank you very much.
Okay, we have the P-Tech sensor bot. Are you guys ready to go? P-Tech?
Hi, so we designed a sensor robot using Arduino board, integrating multiple sensors such as like gas, temperature, tilt, what was the other one? And ultrasonic. So, and like this one will like navigate, I guess, to like seeing different obstacles, and it would have a red light, and it would stop and then change direction based on the input.
So our goal is to build a robot that uses environmental sensors to provide feedback back to the driver. We accomplished adding a tilt sensor, temperature/humidity sensor, light sensor, gas sensor, and ultrasonic sensor. We also added a Bluetooth module to communicate with the robot through our Android phone or anything. We also programmed an Intel Edison to read the output data from the sensor bot and send it to a workstation, like a computer. We had some difficulties wiring sensors to the Arduino correctly and uploading the code, since this is most of our first time doing this. We had to troubleshoot the motor driver chip, and we solved it by using the transistor and diode to operate the motors to work independently. From all our difficulties, many of us learned how to use an Arduino for the first time, and more about computer engineering, especially from our difficulties with the various sensors. We learned to use more advanced wirings with the breadboard. We had a lot of trouble with having a Bluetooth module with giving feedback from the sensor bot to an Android device. We repeatedly encountered bugs in our code and had trouble uploading the code to the Arduino, so we did the best we could. So. Now we'll show you a demo of the working sensors. So, first, we will turn it on, and then, yeah. Unfortunately, only one of our motors is working at the moment. Yeah.
Hit it again.
So it stops and goes, and we wanted to use this to be able to send signals to an Android device, but in lieu of that, we have a red sensor, meaning that it's okay if the environment is okay. If it turns red, it means the environment has some issues. So over here, we have a gas sensor, but I learned that today that the gas sensor has a 12-hour burn-in period, so it's not very accurate at this point in time. So it's still red. It can't be different from what we have. It disappeared when I disconnected it. And we have a temperature sensor over here. Over here is ultrasonic, so the light should turn red momentarily. Or not, if it doesn't feel like it.
Just keep it.
Oh, there you go. There's a slight delay. And you can show data. Here we go.
We also had the Intel Edison connected to the Arduino here, and it was reporting the data back to my computer screen, but when we unplugged it, it disappeared. So unfortunately, it does update the data. It shows you the sensor data live on the screen, but there were too many wires and it got tangled up, so couldn't show you that. The idea with the Edison was to use the wireless features of the Edison. So the Arduino by itself doesn't have wireless capabilities, so it would read the data from the Arduino and then shoot it out to either a remote workstation, because usually these things, if the idea is to use this on another planet, and Mars is pretty far, so you obviously need some kind of wireless capability to communicate. So that's what we use the Edison for. And anything else?
The light sensor works.
The light sensor works.
So if you're in an environment where the light is really harsh, which is not suitable for a person, this can tell you that you shouldn't go in there. See, it lights up red when the really bright light shines on the light sensor.
Good job, guys.
Oh, by the way, my name is Mr. Lewis. This is Mr. Leung. This is Devon, City, and Amir. These are high school students, and we're their teachers.
Questions? Questions from the judges? Any questions?
Really good job, guys. I know working with hardware is tough. Sounds like you guys have pushed through and got a lot of stuff working, so congrats. Good job, guys.
Thank you.
That's especially considering we had a lot of limitations and hardware challenges. That's really great that you guys put that together. Okay, so next up, we have Share Space Science coming up to the stage.
Hi everyone, we are Share Space Science. My name is Yumi. Mariana Omar here. Actually, before I present, I would just want to mention that there's a team that we had an exact same idea. So what we're going to show is going to be very similar to what they have prepared. And also many teams use similar API, so it might look similar to theirs. But we just wanted to bring it up because it's totally different implementation. So say there's somebody special for you, and everybody has somebody special. And their special day is coming up, and you want to surprise them and congratulate their special day with a special message and special image that is provided by NASA, the cool pictures that was posted on the birthday or special day of yours. Special someone. So you come to our website and you pick a date of this. You pick a special day of somebody and hit send. And our backend is running behind and fetching all the pictures that were published by NASA from 2015 all the way back to 1996, where data is available. So you can, there's a description below, and you can go through the pictures and see, what's going on outside the world when it's a special day for somebody. And Omar.
I was just gonna mention that we intend this in the future to be even more personalized, so you can send emails. We try to use the Spark Post, but we didn't have enough time to implement that. And maybe like a picture, we also found an API of you could take pictures of a place at a certain time. It gives you a satellite picture of the whatever location coordinates you provide. And we could personalize that more to provide pictures of your house, or how was it when you were born, or etc.
So for me, one of the most interesting aspects of this hackathon was it quickly became a human experiment of what happens when 3 people come wildly unprepared for a hackathon, as there were too many interesting challenges. And we basically started at like 7 p.m. yesterday when we finally landed on what we wanted to do. And this was the result, and it was great fun.
Part of hackathons is the experience, so I applaud you.
Thank you.
Well, and I think yours and the other one, that what I thought of is, so often people don't understand what we do at NASA, and that we have so much great data from space and great photos, and just things that would really be meaningful to them. And so to have a mechanism that brings it out, like, hey, this is here, it belongs to you, and happy birthday. It's a really great thing. Thanks.
Okay, coming up next is CMoreBot.
Okay. Hi, everybody. We're CMoreBot, and CMoreBot believes that data can change the world. We created a robot to empower citizen scientists around the world because our communities are increasingly at risk from environmental hazards. This is our team, but we'd like to acknowledge that there are some people who aren't here. We have team members in Florida. We have team members in Philadelphia and New York. And New York. So we've worked on Google with them through the Hangout and kept working the whole time. So shout out to them. So we just want to talk a little bit about some stories around this.
So a little over a year ago in Bangalore, India, I lost my grandmother to an asthma attack. If there had been a way for us to test the air quality outside and warn her in time before she went outside, we would have been able to prevent the asthma attack that ended her life.
When I was in college, I lived in a sunny beachside town in California called Santa Cruz. A close friend of mine lost both his parents within 2 years of each other and many of his neighbors to some kind of mysterious environmental chemical, and perhaps radon. We still don't know.
My brother and his family live in Royersford, Pennsylvania, and his wife has Hashimoto's disease. Their dog recently died of Hashimoto's. That's a thyroid illness, and when I Googled, I found out that's often related to radiation. My brother lives within 5 miles of a nuclear power plant that's really aged and is quite known for that. So I have already been on a quest to start testing water, and I currently have a unit that's Arduino that will be installed on Monday, tomorrow. So, and I am on a quest currently, and I'm going to find out the truth about it.
So what if we had the ability to inexpensively test for environmental contaminants on Earth? Now we do. It's called CMoreBot. And we created it using Arduino, the Intel Edison, a bunch of sensors, and we even made it a cozy to protect it from the weather. That's made of, oh my gosh, fiber optic fabric, and if it was dark, you could see it glowing like space. So the problem we encountered was air pollution, and the solution we decided upon was a dust sensor, which works with Arduino. If you had a radon problem, like I believe my friend did, the solution is a radon sensor. And, and in the water, the solution for the water problem could be any kind of radiation sensor, and there's a lot on the market that are available for hardware use. So we just wanted to leave with a few ideas that we believe that data and empathy can equal social change.
It can lead to environmental change.
And community engagement.
So please, if you want to see a quick demo of the robot, we'd like to use the last few seconds of our time to do that.
Yeah.
Oh, yeah. Is it going to work?
Yeah, it's still loading.
It's loading. The robot is loading. And he has a camera. Also, all the data can go into a website, and we have that up too. I'll show you. Let me move to that one. So right now we're pulling in API data from another location, but we just wanted to demo to you that this is the kind of interface we could use to stream the data from the robot about environmental contaminants. The robot is really inexpensive and could be distributed to communities all over the world. Also, if there was any nuclear power plant problem, no person wouldn't have to go in. You could just send in the robot, which is why it's so much better than a suit or a glove or something. Anything else?
No, I'm happy.
That's it. Thank you.
I want a special shout out to Untitled Edison and also for NASA for letting us mentor girls on Friday. Thanks so much for that.
Yeah. Thanks again.
Any questions?
You guys spoke to sort of the flexibility of the robot, you know, with different sensors. Can you talk a little bit about the modularity? Can you, how easy is it to modify?
Sure. So the particular packages we're using, we connected the sensors directly to the Edison. And we used a variety of sensors. You know, we plan to have some for wind speed. There are some sensors that we already found that do various different types of gases and dust. So it looked like they all pretty much function in a very similar fashion to the ones that we're using. So it'd pretty much just be a plug and replace and a minor software change.
Cool. Thanks, guys.
Thank you.
Okay, thank you, CMoreBot. SpaceSloth, please come up to the stage. SpaceSloth.
Hello, so our group was SpaceSloth, and the name was approved by our resident astronaut, so that's why we used it. We didn't have time to actually think of a name. But what we did was we created a wearable navigation technology that can be implemented in numerous situations. And so what we did was we used an Intel Edison in the top here. And we connected a bunch of near field, far field, and other sensors to get visual data and light data to actually help help autonomous robots or astronauts navigate whatever kind of obstacles or situations they might face or be in. So over here we have in the 360 view we have near field and far field sensors. We have a LiDAR at the front, using laser technology to sense anything directly in front of the robot or person using the device. And in the back we have, in all directions we have the near field sensors, which sense within a proximity of 30 centimeters, that tell you, that give you infrared data. So they warn you or they tell you about objects that are coming at you in that proximity. And then we also have a camera at the front to tell you color data, and we actually implemented something that allows you to track other objects. So now we're going to do a brief demo and some of the color showing stuff. This is just the output of a few of the sensors that we implemented. This is the SpaceSloth is for the color data. So this is an example. If the astronaut or whatever robot or something is using the technology, they would have that sensor underneath, or they would be receiving the data that's now streaming to the iPhone and the Google Cardboard that we're using. Show them the proximity. Sorry, just some technical issues. Yes, she's our resident astronaut. So just watch on the screen as it should respond to proximity. Wait. Is it going? It's not updating. Fuck. Why isn't it updating? No.
Well, it's updating on my screen.
All right, just show on the screen.
Everything is live.
Yes, everything is connected via the web. Give us a second. I'm so sorry. If anyone has questions while we're getting this worked out. Yeah, sorry.
Okay, we can go back to the prototype.
All right. So there's something immediate. Is it working?
This is the prototype.
But did we mention we have a phone and the Google Cardboard here, so I can actually...
Can you connect the other laptop to the screen?
Yeah, connect the other laptop.
Okay, come on.
Yeah, just bring the laptop over here. Sorry.
It's working.
It is?
Yep. So just refresh it.
All right. Can we... Yeah.
On your laptop? On hers.
It's refresh? Do the judges have any questions while we're figuring this out?
Can you connect the other laptop?
You classify this as augmented reality? Is that how you think about this?
So the challenge that we're working with is actually the sensor self challenge. So it's not so much augmented reality as a sensor technology.
Okay, thank you.
Infrared sensors, the squares turn lighter and darker, and the shade is dependent on how far away the object is from the sensor. So as with her, she could see inside the same thing that you can see here, and as she can see the middle square there is light, so that means there's something right in front of her. She can turn left or right. Now the left sensor is being blocked, and so it's lighter gray, so she knows she can't go to her right side. I mean, this is the right side. And then this is.
It's only updating on the laptop. I'm sorry.
No,
Yeah.
it should be on your computer too.
What?
It's not. Are you on the Intel Edison?
Yeah, I am.
Oh, is it 192, 168? Oh, it's 109, not 100. 109.
Magic.
Yes. There you go.
All right. So if we
That happens in real life.
see how both of the sensors where both of our hands are at the side, and now if I move my hand to the middle, see, so it responds in real time, and then we also have the color data. Oh shoot.
Live coding.
If you wait, just keep it.
So this camera here can see red.
Do you have the tracking?
And that is on the computer.
No, you're not. Do you have the tracking?
What?
Sorry, the tracking. The
What's
other.
tracking here? But we don't. It's not on here.
Oh shoot.
We took care of this.
This
Okay.
is mission control. What it looks like.
All right. So sorry we had the problems. That was our live demo.
We can show you something working afterwards again.
Oh, it's working. It's working. It's just
Live coding demo. That's cool.
You guys,
Any other questions from the judges?
Well, I was just going to say that we've all done, real-time operations. They never, there's a lot to do, and what I think is interesting is, the team communication, which you clearly have as a team, where you're saying little half sentences to each other, and you know each other means, and it's what it's all about. It's and there's a lot of things that are connected to a lot of different things. I like what you were thinking about in terms of the big picture of basically how can we help people know where to go, or how can we help robots know where to go in a more autonomous way. And I think by putting a lot of sensors on a person, or on a robot, it really helps all of us understand what we can do.
Thank you.
Okay, coming up on stage, thank you, SpaceSloth. Wildfire Navigator now presenting.
Hello everybody, this is my colleague Kishore, and I'm Alex. And today, we decided to take a challenge. And well, it's not one of the challenges that was posted on the website, but we decided to save lives. So we created an application called Wildfire Navigator, which does what you might think it does. The problem that we found was that there are about 340,000 deaths every single year due to wildfires around the world. So, and that to me seems like a very large number. So what we decided to do was to create an application which people will be able to use from their smartphone by using their location so that they can navigate through the wildfires on the safe route out. So this is our application. It's capable of discovering where wildfires are around the world and also navigate people on the safe routes. Some of the data sets we used are the MODIS dataset, which is coming from NASA from the two satellites, Equa and Terra, and also Google Maps API. Intel Edison is going to be used and presented by Kishore too. And now we're going to show you the demo. Just 1 second. Okay, so here we are. If you look on the app, this is the mobile phone app. It's loaded on my screen. What you can see here, this is New York, when everything is nice. But last time I checked, like 10 minutes ago, there were about like 1,600 fires around the world. And that's coming from NASA. And what we do now, I found one of these fires, and I put in the destination and in the source and destination fields, I put these coordinates where we can find one of these wildfires. So what we'll do next, we'll assume that we are in the middle of one of these wildfires. So we're going to press route, and here we are. So the point A is where we are now. The point B is where we want to go. And the red dots are wildfires that are happening right now in Venezuela. I can zoom out. So what you can see here are two routes. One that goes through the route, through the wildfire, which is given by Google Maps. And the second one is an alternative to that one, which will get you to your destination on a safe route. Now I'll let Kishore explain what he did also.
A lot of times there will not be any time for you to check the phone or drive off in a location. You have to get into car, get out of the place, and go somewhere. So the part we worked together was mainly integrate this into a connected car experience where you can basically have a kind of feedback from Internet of Things. So I worked on Intel Edison, a small app. Basically, what it does is it kind of gets feedback from your mobile phone locally, and also it can get some feedback from over the cloud, and also some sensors. So like for example, there is a lot of heat going on, then it can detect that based on that, and it can turn red. So and then if there is no heat source, it can turn blue. So these kind of applications we can develop, and basically it lets you off depending on one sort of device where you have to constantly type and do such things, rather than Internet of Things is supposed to give you an experience rather than engaging you. All right.
So also to end this presentation, I'd like to show you some of the future work that we can do. So what we can also do is to make predictions about how these wildfires will evolve based on the wind direction and strength. And you can also send alerts to the communities that are endangered so that they can go up in time. Thank you. Does anyone have any questions?
Any questions? Okay, thank you. Thanks, Wildfire. Okay, coming up to stage now is Mediprint.
So my name is David, and John and I, John Oquist, we decided to attack the challenge of the med kit in space. I think it was called 3D Astromed devices. And the basic idea being that if you're on the ISS, or worse, if you're on a mission to Mars, the closest hospital is quite far away. So the question is, what's the ideal med kit to carry into space? And our answer is that it's a med kit that can transform to your needs. Big surprise. Yeah, 3D printing is a thing, and we're going to explore it today. Here we go. All right, so we fired up Mediprint. What do we have? We've got a UI where we can select the injured crew member aboard the ISS. I think today Buzz and John are off the hook, but poor John Doe over here, he got injured during the course of the mission. It's that red shirt, I'm telling you. Which part of John's body was injured? I think it was his left arm. And although on the ISS it is very common, don't be so close, okay. Although it is very common to break a finger on board the ISS, or perhaps an arm, today John here suffered a wrist break. And you notice that this is something that we can build out of standard plastic. It's very light, easy to ship on board a space mission. I'd be lying if I told you it wasn't cool to print one out and try it on myself. So big respect for John for getting these models together. Here we have it rigged up with some Velcro to go around my arm. But the really interesting thing, though, about space and 3D printing is that astronauts are actually scanned before and after their missions. So we actually know their dimensions very precisely. And if there are any modifications, any variations due to musculature, atrophy or hypertrophy, we can customize these models to fit a given astronaut. And so for a demo of that, when we go to print it, we can actually customize a given mesh to someone's anatomy. Print it, get a perfect fit. Like so. Thank you.
Well, I like that use of data that we're already taking and then thinking how can we use that to prevent things that would be tough to deal with. And you mentioned common to break fingers. I wouldn't actually say that's true. When I think about what would be the most likely thing that could get broken, fingers come to mind for me because they're just the smallest. In terms of you'd actually have to hit something pretty hard to break an arm or a leg. Although that scenario is not as far away as you'd think, in that if you're flying through the station, if you end up running into something that's fixed in place, you're actually bringing your 120, 30 pounds or 180 pounds of force, as you're flying by. So things definitely, I think, could get broken, but I think of the smaller things first. I was especially intrigued at the end there, because I think your dimensions will change in space to a certain extent due to exercising. So you think that you can visualize the model and then say, okay, so she ate a lot of Girl Scout cookies up there. Let's add on a little, and then you could actually design the cast from there.
Well, I think that if you can take a couple key tape measure measurements in space, I think you can identify that. I think that skeletally, my understanding is that we don't change that much, but it's more the soft tissue that's going to change. So I think if we combine a pretty thorough, musculoskeletal model that's taken on Earth as a baseline, and combine that with tape measurements in space, we can arrive at a fairly good estimate. I haven't combined his research with my own, but I do have a friend who performed his PhD thesis on this exact topic on creating statistical shape models for the bones of the body.
That sounds great. Another application in a different way would be we run with harnesses on the treadmill, and actually how those harnesses fit is extremely important and actually really difficult. And you do this, for half an hour a day, and often people, have injuries from the harness. And so understanding the model of their body before they go and, designing harnesses in that way, it's a great idea. Thanks.
Great, thank you.
So we will be moving on to the next presentation. Emis, correct? Emis.
Okay. So I'm Abby Strobel, and this is James Chambers. We're both from Rutgers University. We chose to work on the Spacey Sounds Challenge, and we both like white noise, simulators, and ambient sounds, so that's what we wanted to focus on. And when I was the one that was sort of looking through all the space sounds, and I named it Emis before radio emissions, because that's how a lot of the most of the space sounds from the websites were from. So, do you got it?
Yeah, so this is the prototype of the app. Sorry, this is the prototype of the app. So we don't have all of the features implemented, but you can at least go and click on different planets to get I have to set up the audio. So there's not a central API right now for getting like sounds from NASA, but we picked a few out, and the idea is that you'd be able to like explore an interactive galaxy or just all of space, and you click on different planets or objects. Like we wanted to have spaceships and things, and you would hear recordings related to that, and it would also display information related to the recording, so there would be an educational aspect to it. And there'd be more controls allowing you to like mix together the different sounds and just create an overall mix of like ambient noises, and then you can share it with other people using some messaging service. So that's all.
What's the appropriate age group, do you think, for this?
Well, we'd like to make it pretty, have a broad audience, like a wide range. It would kind of depend on the information we pull in about the recordings, like how presentable it is for younger audiences, or we might have to like write up descriptions for younger kids. But ideally, it would be like a nice, fun, interactive thing that kids and adults could enjoy.
Can you be a little more specific about where the recordings are from?
So there's not like a central collection of these. So there's just a bunch of links from different NASA websites where we just pulled off the sound files. But ideally, we could either create a database or there would be a NASA API for getting sounds. So.
Any other questions? I actually have a comment. I think it would be great if you had a plugin or something with a waveform for accessibility. So if I could see the sound represented as a shape, that kind of a thing. That'd be pretty cool.
Great.
Thank you.
Thanks, guys. Okay, we have, which planet am I on?
Good evening. Let's see if it works. My name is not Marilyn, that's someone else. But hi. So as our technology gets better and better, and we get more people going into space, we're eventually going to become more of a spacefaring species, right? So that's going to open up a whole box of questions that we can't even anticipate. So some questions I anticipate consumers will be asking in a couple years when space travel is more common is, which planet am I on? Or, which planet are my friends on? So my website aims to answer both of those questions. So if we check it out, y'all can check it out too on your mobile devices. Which planet am I on? .mybluemix.net. And Now, I had some issues testing. I really hope it works. Yes! Thank you, thank you, thank you. Even better is if I want to share with my friends, see what planet they're on. Who else is in the neighborhood, right? I can tweet it. There we go. I'm on planet Earth. Which planet are you on? And we can tweet it. There we go. Now if we want to get a live stream going, refresh on a Mac. No tweet results. It's probably Twitter, yeah. Let's try again. I've already, of course. Anyone else want to post? Well, trust me, eventually it'll be up there. That's another feature we can add. Maybe have our own interface where we can, share with friends ourselves, so we don't have to rely on Twitter. Some other expansions, I'm hoping to not limit it to planets, but other celestial bodies like, asteroids and moons. So. Any questions?
Yeah. What's going to happen if you're not on a planet? Say you're in transit or lost in space.
That's another good feature to add to that. If we have any astronauts that can test this, like that on the space station, maybe we can get Curiosity to try it out. See if it gets
funny you should say that, but I'm embarrassed not to remember the name, but I'm pretty sure there's an ESA app, European Space Agency, that Samantha Cristoforetti is trying out right now, where basically whoever are her friends, I think on Twitter.
Friends in Space.
Friends in Space. Yeah, there we go. We talked about it, right?
Well, the fellow that made it, Alex Piacetti, I believe, was one of our Hack the Universe participants at the American Museum of Natural History.
So I'm pretty sure. So Samantha's up there right now. Has been up there about 5 months. She's got about another month to go, and I believe that when she's actually flying over their city, the actual trajectory, the real-time data, then they'll know, right?
You can wave hello to Samantha, and she'll get it when she flies over you.
Isn't that great? I'm pretty sure it's working.
That's pretty cool.
Okay, last we have /transcript, /transcript. The team is called Commander Kittens, as I understand.
Right.
Woohoo! We're the last people. Does that not feel good? Like everyone's like, finally it's over. I can go home.
Actually, I think everybody's just happy to meet the person that designed the Space Cat t-shirt.
Oh, I didn't design it. I just acquired them.
No. Hey, you made it happen for us, and thank you.
Thank you. Oh, that's an astronaut.
Space Cat
Like
t-shirt.
this astronaut at any point in time, she could just be all like, hey, I've been in space. What have you done? All right, last prezzo of the day. So you get an email from your mom or your loved one or your child, and it says like, I miss you. And you read it and you go, oh, that's cute. You get on the phone with them and you hear them say it, and you hear tone, you hear the pause, you hear the inflection of their voice, and suddenly that I miss you becomes something totally different to you. And it has that kind of emotional response. We went through all the NASA sound clips, and when you're listening to the shuttle launches, it is amazing. If you have not listened to them, you really should. You hear the music they're listening to, you hear like all the kind of chatter back and forth, and we thought this is such an emotional thing, we want to create kind of like an emotional experience around it. And so we've seen a lot of people create solutions and actively try to solve problems, which is completely awesome, and we look at these things, we think they're awesome. For us, we just wanted to create something that was how we feel about space often, or how it makes us feel bigger than us, and it's emotional. And so what we ended up doing is we worked on a project and we called it Transcript. And what we did is we basically took the audio and we created kind of transcripts of them, like automatically went in, pulled out all the transcripts, we ran it through a service, And then we try to contextualize those things. So we looked for, we used a little bit on the back end. It was something that we have, Azure. And yeah, there's always going to be cats. I have no shame. Cat lady, I'm out. And it kind of goes through some natural language processing, and what it does is it extracts all the text from the audio for you. And we start to look at those like certain phrases and those words and frequency and things like that. And what we do is then we enrich that data source. And so we start to say, okay, based on this stuff that has happened, like first like Apollo 11, what are the news articles that are happening? What are the pictures around there? How can we enrich this experience and make it a little bit more emotional than just the audio? And so what we did is we created a Connecting Unity 3D installation, and it's, purposely abstract. And we want to kind of just say, okay, here's an emotional experience that you can have, an emotional installation based on some of that audio. So we're going to demo it. That's it. You saw it. Did you feel confused? Achievement unlocked. Yeah, we said it was abstract. It's not projecting. Oh, wait.
Neil
No.
and Buzz,
It's not projecting.
the President of the United States is in his office now and would like to say a few words to you. Over.
Sorry, technical difficulties.
Would be an honor. Go ahead, Mr. President. This is Houston now.
We'll try it again.
Second launch? Failure to launch?
Hello, Neil and Buzz. I'm talking to you by telephone from the Oval Room at the White House. And this certainly has to be the most historic telephone call ever made. I just can't tell you how proud we all are of what you... For every American, this has to be the proudest day of our lives. And for people all over the world, I am sure they too join with America in recognizing what an immense feat this is. Because of what you have done, the heavens have become a part of man's world. And as you talk to us from the sea of tranquility, it inspires us to redouble our efforts to bring peace and tranquility to Earth. For one priceless moment in the whole history of man, all the people on this Earth are truly one. One in their pride in what you have done, and one in our prayers that you will return safely to Earth. Thank you, Mr. President. It's a great honor and privilege for us to be here.
That's it. Thank you.
The United States, but and
Any questions? Questions? No? Okay, thank you. That's it.